incredible, actually. So now I'm just going to be handing over to Laura Griffiths, and she's going to be presenting the panel session for the TCT Women in 3D Printing Innovator Award. It's Meet the Innovators 2023. There we go. There's Laura. Just need to turn your mic on.
Thanks so much, Greg.
Okay, I'll leave you to it. Thank you.
Great, thank you. Hi everyone, so we're just rounding up our speakers now for this Meet the Innovators panel session. I have the very exciting job today of announcing our finalists for the TCT Women in 3D Printing Innovator Award. For anyone who maybe doesn't know some of the background on the TCT Women in 3D Printing Innovator Award, it basically came together as a collaboration between the TCT group and Women in 3D Printing to really highlight the work and the achievements of women in the additive manufacturing and 3D printing industry. And I think we may have all of our speakers now. I just want to double check before we kick off too much. Okay, not quite. Okay. And just a bit of background on TCT. So my name is Laura Griffiths. I'm head of content at the TCT group. We are a producer of events and publications on the additive manufacturing and 3D printing industry. And we've been doing that now for just over 30 years, so a long time. And we've been collaborating with Women in 3D Printing since 2017. So we've been doing this to bring woman-led panel sessions to our TCT 360 event in the UK, and then also our Rapid Plus TCT event over in the US, which is organised by our partners SME, who have been very kind enough to have us on this stage today at TIPE. So the first Women in 3D Printing Award was awarded back in 2019, and it was awarded to Wai Young, who's a professor at the Nanyang Technological University. And after a couple of years away due to the pandemic, we were finally able to award our second winner, Eliana Fu, Trump Industry Manager, last year. So this year, excited to carry on, and we had a total of 94 nominations from the public this time, which I believe is the biggest number of nominations we've ever had. So it was a really impressive pool of nominations. But then TCT and Women in 3D Printing had the very difficult task of having to whittle that down to just the 5 nominees who will meet in just a few moments' time. And I'm sure you'll all agree they're very, very much well deserved. And at the end of today's panel session, we'll be pushing the responsibility back onto you in the public to vote for this year's 2023 winner of the TCT Women in 3D Printing Innovator Award. So let me just make sure that all of our panelists are here. It's all very secret. It's all very hush-hush. Okay. Hi, Kate.
Hi.
So just inviting all of our nominees on here. So we have Dr. Kate Black. Alba Gonzalez Alvarez.
Hello, everyone.
Hi, Jessica. Jessica Drasber.
Hello, everyone.
Hi, Paristu. I'm Dr. Paristu Jamshidi. So I believe we are just missing one speaker now. Hopefully they'll be able to join us shortly. But welcome our finalists for the TCT Women in 3D Printing Innovator Award 2023. So just do some very, very quick introductions because I do want to get into asking you all your questions. So we have Alba Gonzalez Alvarez, who is a doctor in biomedical engineering and currently leading a European Mercury Connex Plus medical devices project in Madrid. Dr. Paristu Jamshidi, doctor in biomedical engineering at the University of Birmingham. Beth Ripley, Deputy Chief Office of Healthcare Innovation and Learning at the US Department of Veterans Affairs, Jessica Drasber, Director of Resin Product Development at Carbon, and Dr. Kate Black, Professor at the University of Liverpool and founder of metal AM company Atomic. Hi, everybody.
Hello.
I'm very excited to have you all here today. This is such an impressive group. And as I said at the start, whittled down from the highest number of nominations that we've had so far for this award. So well done and congratulations to everybody.
Thank you.
So I really do just want to jump straight into the questions because we've got quite a few to get through and we've got so many different areas of expertise here today. So I guess to start with, I just want to learn a little bit more and present to the audience about what led you all into additive manufacturing, your current roles in the AM industry and current areas of interest. So I think, Kate, you were the first person on. I'm going to pass this question to you first. So tell us about your journey into AM and what you're doing right now.
Yeah, okay, great. Thank you. Hi, everybody. So I'm a professor here in manufacturing at the School of Engineering here at the University of Liverpool. I'm also an entrepreneur. My background is really in chemistry and materials. And I started my journey into AM relatively late into my career, really. It wasn't until I was appointed as an academic back in 2013 that I started doing research in additive manufacturing. And I started processing some of the expertise that I had in organometallic chemistry and translating that into additive manufacturing. So I came at it from a chemistry point of view, and that allowed me to develop a novel 3D printed metal process, which I then later took on into a commercial sector, where I was the co-founder and CTO of the university spin-out Meta Additive, which was acquired by Desktop Metal back in September 2021. So really, I kind of specialize in materials and try to broaden that palette of materials that we can process in AM. But I'm also a big advocate, really, of trying to push for a much more diverse workforce so that we can create innovation in manufacturing. And that's me, really, in a nutshell.
Great, thank you. And Alba, I guess you can go next.
Sure. Thank you, Laura. So my current role is, as you said, I'm leading an European project on the development of innovative medical devices in Madrid, in association with several hospitals in Europe. So we provide a service to hospitals for which we develop custom implants to real patients that require surgery to get complex bone defects fixed. We develop a great variety of devices in maxillofacial, orthopedic, and thoracic surgery. And also we carry on research work to keep validating new devices biomechanically and also new processes, and build a little bit the state of the art that guarantees the beneficial application of 3D printing in patients. And what led me to additive manufacturing in the area of patient-specific implants, because we develop one design for one patient, additive manufacturing allows us to create single components with a relatively quick fast turnaround time to meet surgery deadlines. And obviously, as we all know, we are capable of manufacturing complex geometries. And above all, in the medical industry, it allows us to create porous structures, which have been paramount to improve the osseointegration of the implants we develop and to promote the regeneration of bone. So that's it from my side.
Great, thank you, Alba. Jessica, to you next.
Hi, everyone. I'm Jessica Drasba. I'm Director of Product Development at Carbon. In this role, I have worked on defining and implementing Carbon's development and commercialization process for new resins. It's worth noting that a cool resin invention is exciting, but without a proper commercialization process, it's just an invention. It's not actually a resin product that a customer can use. So my team is involved in making sure that all the inventions that come to light for Carbon actually become real products that customers can use on the resin side of our business. In particular, my team ensures that resins have been properly defined for our customers' needs. They have a full set of requirements. They're designed for robustness. They've been scale-up has been considered, and all other commercialization considerations have been considered. In terms of getting into 3D printing, I started with an interest in polymers in college. I was just interested that polymers can really lead to advanced properties in bio and also in the manufacturing world. Going into grad school, I decided to go to UC Berkeley to work on organic photovoltaics, which are basically just semiconducting polymers. So again, very advanced polymers for a specific application in the case of solar generation. After grad school, I learned about two-photon absorption, and I was so impressed with two-photon absorption. It kind of went in this world of using light to make something, like my PhD was in, and I couldn't stop thinking about stereolithography. At the same time, my mom was and transitioned from being a high school math teacher to a high school engineering teacher. And she was developing this whole new engineering curriculum for her students, and it included a lot of 3D printing. She, of course, wasn't using light-based 3D printing. She was using FDM. But nonetheless, my mom and I would talk all the time about 3D printing. And when I saw Carbon's TED Talk, I just knew I had to try to get involved. And luckily, I got hired and never looked back.
That's great. Paristu, what about you next? I think might have a bit of a connection issue there. We'll jump back to Paristu in a moment. And Beth, thank you so much for joining us. Great to have you here. Tell us about what got you into the additive manufacturing industry and what you're currently up to, and introduce us to your friend there as well.
This is Raven. She's very interested in 3D printing too. Hi, everyone. My name is Beth Ripley. My background is in radiology. And so, I started in the darkroom, I like to say, looking at patients' imaging. And, it's actually a really fun and rewarding job in terms of you get to see a lot, but it's actually really difficult to figure out or find the words that are needed sometimes to describe really complex anatomy and pathology in a short report, to somebody you may never see anymore. And, it turns out, on the toughest cases, those words are often inadequate. And so the surgeons and their teams would come down to see us, and we kind of try to walk through images and really try to explain, again, really complex patient anatomy with the, pathology or abnormalities on top of it. And at that time, this is kind of right when 3D printing started to get, some small bit of traction in the medical field, being used for things like conjoined twins, separation, etc. And so we started thinking, what if we could just take, 3D data sets, which is really our body, that are being kind of smushed into this 2D or two-dimensional world, which is imaging, and just put it back into 3D using 3D printing. And that's really where I started. And so, as a resident, trying to learn all of the imaging and all that, communication, but starting to put things back into 3D printing. So that's where it all started, with a good friend and colleague of mine as well, Tatiana Khalil. And so we would 3D print almost, anything and everything, really triggered by when surgeons would come down, because those are the toughest problems. And, it was really helpful. It was really rewarding to see what you could get, because, again, these conversations can be 30, 40 minutes going through, but if you put the actual patient anatomy back in the hands of the surgeons, they would get it in seconds. Like the amount of information transfer and communication that would happen in that moment is just amazing. Almost sad, because, right, you worked so long to make it. They'd be like, I got it, put it down, out I go. But, again, fast forward to now, I'm really lucky to be working in the Veterans Health Administration. Here in the VA, our mission is to provide care for veterans, and not only just care, but top-notch, best-in-class care for veterans, for each and every veteran. So the work I've been doing over the past several years is bringing that ability to harness 3D printing to communicate about, disease processes and patient's anatomy, and, really amp that up to the level of patient matched care. Just, again, I think the heart of what I want to talk about here is just, being able to communicate to surgeons, being able to communicate to the patients, et cetera. And I'm happy to say that we have 3D printing capabilities in 99 hospitals across VA now. And we're, again, just continue to work on and understanding what's next for this technology as we kind of harness it at the point of care.
Great, thank you so much. As I said, we've got such a diverse representation of industries and expertise on this, so I'm very much looking forward to digging into those different areas now. And hopefully we'll get Parasu to be able to rejoin us shortly, but if not, I'll give a bit of an introduction to some of her work before we finish the panel session. But let's dive into some more questions then. So I'll go back to Kate first. We'll try and go around in circles. So Kate, interestingly, when I first joined TCT around 8 years ago, you were the first woman I got to actually sit down and have a proper conversation with. And I'm pretty sure actually I'd already been in the industry for quite a while first when that happened. So it said a lot about the amount of women in the industry at the time, really, that it took that long. But this feels extra special now to have you nominated and on this panel session today. So you talked at the start about all the work you've done, of course, at University of Liverpool, and then with your company too. I'm very interested to know about the process of developing a new metal additive manufacturing technology and then getting it to a point where it could be ready to be commercialized. Can you talk to us a little bit about that?
Yeah, I mean, it's pretty hard to condense down, and I'm still can't believe it that we did it, but we did. So I think because I came at additive manufacturing from a chemistry point of view, my PhD wasn't in additive manufacturing. You know, it was in chemistry, and in fact, it was in depositing really thin films, so the complete opposite of what I do now. But I think it was that allowed me to see problems at a different, come at it from a different angle. And I'm a real firm believer that, particularly in manufacturing and additive manufacturing, we need to take people from all the seemingly disparate disciplines, so people from chemistry or physics or biology, and see what they do, turn it on its head, because to me, everything is about materials. If you don't have the materials, you can have the most amazing machines, you can have amazing software, but if you don't have the materials to put into it, then you're not going to manufacture anything. So I think I saw that there was a need in the material space. I believe that what I'd learned in my organometallic side and my thin layer side could be translated. I also took this is quite crazy, but I took some inspiration from my husband's work, who is a geologist. So he looks at sedimentary rocks, and I saw how rocks are formed over time. And I thought, I wonder whether we could make that in, instead of man-made time, in a machine. And that's really how the meta additive journey started, if you like. So it started in the university. I quickly realized that actually this had legs, and it could be really a powerful tool if we got it in the right hands. So I set up meta additive back in October 2019 with some of my colleagues. And I've got to say, really, that having a great technology is only part of it, and it's only part of being able to get it to commercialization. Really, it's all about people and team. And if you don't have the right people and the right team, great innovation can get squashed. So I think for me, it was that synergy of having a good technology, but also having a really great team to take it to market.
Great, thank you. It sounds super exciting, and it'd be great to find out more in the coming months and years what happens with that. Let's go to Jessica now. Jessica, you talked about materials at the start, and when it actually gets exciting in the process of materials development. And you've been at Carbon pretty much since the beginning. Like you say, that impressive TED talk that we all saw, and we saw this part grow in what felt like just seconds. And you've been responsible for leading this team for the development of resins. And as we see all the time, there's always amazing applications coming out of Carbon for a lot of end use, even consumer-facing products. Some really impressive stuff. Can you talk about how materials development is really enabling some of those applications to come to life?
Yes, thank you. As you mentioned, Carbon has enabled a lot of new products. Probably the most well-known examples are ones in the elastomeric lattice space, such as Adidas midsoles. And I actually have a nice example here, if not everyone has seen it already. Super cool, just something you can buy online because there's already millions of pairs that have been manufactured with Carbon's technology. So just to be clear, it's the midsole down here that carbon materials have contributed to. In addition to running shoes, though, there are many other applications that carbon has enabled. Things like helmet padding, which you can see with the NFL players here in the US these coming weekends with the playoffs. You can also see bicycle seats, backpack cushioning, gloves, custom wheelchair padding, all sorts of different applications, rigid applications as well, coming from carbon. I think carbon really has moved the industry forward because of some of the innovative chemistry approaches that we've been able to incorporate into our materials. As Kate said, materials are the reason that people want to print. Like, you want a nice part at the end of the day. It doesn't matter how fancy your printer is. It doesn't matter how elegant the software is. Those are helpful to making a good part, but really the materials at the end of the day are what's super important. And at Carbon, we were able to come up with some really cool chemistry concepts, including the concept of dual cure chemistry and some kind of elegant, kind of adjacent chemistries to dual cure. And so what we can do with that is make parts with impressive final bulk properties that make the resin suitable for end use applications. Even something like this, that's going to, have a full human's weight on it. The resin doesn't buckle, and it lasts, just as long as a regular midsole material. So very impressive material performance. The way that we go about achieving that is by first talking to our customers and figuring out what exactly do they want their part to achieve. In this case, what do you want a midsole to achieve? My team works very heavily with our product team to translate the requirements of our customers into actual measurable material properties. Because it's one thing to say, oh, I want a durable part, but what does that mean for an engineer who has to go design the resin that's going to go into a part? And so my team really helps to break down the requirements into measurable material properties. These measurable material properties are then used to design the resin against, and eventually to test design robustness against. We really think it's important to ensure our products are very robust so that customers can use them industrially. If it's a kind of one-off invention and we haven't tested the robustness, it's just not going to be a successful product. So having a whole way that we test design robustness, I think, has been very, very important to make our resins available commercially. Once we test design robustness, there's many other things to do too, like set final specifications and work with many other groups to ensure all aspects of the commercialization are complete. Yeah, my team works really on all aspects of development and commercialization. And at the end of the day, I think we have some really impressive parts. And yeah, to echo what Kate said again, it's really about the materials at the end of the day. And so I feel really proud and happy to be able to contribute really in the whole plastic space, but for carbon, to develop these new materials.
Great, thanks, Jessica. And even just myself, just getting to write about this industry, I remember seeing the Adidas trainers on the Adidas website, and it didn't even mention that they were 3D printed. And I found that really exciting because it was no longer about the fact they were 3D printed. It was just because this was the best way to make this product. So it's really exciting to see how that's come on.
Yeah, thank you.
So let's go back to Alba now. So Alba, you talked about the project you're currently working on, and you've really pioneered this use of 3D printing in surgery, developed hundreds of these medical devices that have actually been successfully implanted into patients. And you were recently awarded the National Design Innovation Award back in 2022 for some of your work. Can you talk about your experience of going from designing these very complex devices and reaching that point of successful implantation?
Sure. So the process to develop a custom 3D printed implant for a specific patient starts with the medical prescription for a custom implant. This basically means that the patient has a very complex bone defect that cannot be reconstructed with a standard market implant, and it needs a personalized solution. So we start processing the radiological images of the patient, usually a CT scan or an MRI, and we create a 3D virtual model of the anatomy that we need to reconstruct. And we analyze the case with the clinical team that is going to operate the patient, and we decide what is the best surgical strategy for the patient. We do a virtual planning of the surgery, and we develop all the medical devices that patient requires. because we have been developing custom implants for almost 9 years now. We have developed a great range of implant designs that we have biomechanically tested and validated, and therefore we can now use that knowledge to design and create new implants within weeks, really. So, however, when we develop complete novel devices, we use engineering analysis to actually validate the designs. But in one case or the other, once the design is ready, we 3D print the final designs in different biocompatible materials. We have established workflows for additive manufacturing for each type of implant and medical device that we develop. We usually use powder bed fusion technology for the metallic implants in titanium 6 aluminum for vanadium, and then we manufacture in stainless steel as well, in different biopolymers for templates, anatomical models, different additive manufacturing technologies for the different components. And once we have all the components manufactured, we sterilize them and take them to surgery. And we are really lucky. We have developed implants to reconstruct almost any part of the body, really. Very complex reconstructions, from head and neck to orthopedics, thoracic surgery, femurs, tibias, hips. Last week we had a really complex patient that we operated in Italy for a very complex hip reconstruction, a patient that could have not been operated unless a custom implant would have been created for him. So that process from design to implantation, it's a process that is usually carried out under a lot of pressure, as you have to meet surgery deadlines and you have to organize the work of multidisciplinary teams within the therapeutic window of the patient, the work of clinicians, engineers, manufacturers, etc. But it is a really special time when you see a patient get better because of the work done together by all of us. So yeah, I think it's very special. Yeah.
Great, thanks. Oh, sorry.
Laura.
Yes.
I'm here.
Oh, hi, Paris. Good to have you back.
Thank you. So shall I actually start, or shall I just wait for, because I'm a little bit lost in the between of connection.
Don't worry, we'll get round to you in a second. We know you're here now, so we'll get back to your questions.
Thank you. Brilliant.
But I think you're right, Albert, just what you touched on there, the kind of the awe at the end of, seeing how this can really impact somebody's life. I think very often, even when I try and communicate to people about just how impressive this technology is, it is always those healthcare applications that really help communicate the power of what this technology can do. So it's really interesting to hear that, and especially to hear you say it. Let's move on to Paris now, just in case we do lose connection again. And just at the start, we just got everybody to just talk a little bit about how they got into additive manufacturing and what they're doing. So if you just want to tell us a little bit about how you got into the industry.
Hi, everyone. Sorry about the connection issue. So before I get lost again, I'm just quickly going to introduce myself. My name is Parasu Jamshidi, and my background is biomedical engineer. I did my PhD in biomedical engineering. And the main focus of my research during my PhD was working on a development of the novel approaches and technology to help patients for better healing following any disease and injuries. And as I always wanted to mimic that like a real body, I was always trying, even before I get to the AM, I was trying to create 3D model of everything in the lab by using mold. And since I've actually joined AMP Lab Group at University of Birmingham, we have a very big metallic 3D printer. I started working on 3D printing of medical implants, and I could actually join my expertise and skills of biomedical by 3D printing and using the design flexibility of 3D printing to create a customized patient-specific medical implant. And I'm sure Alba and Beth, I think we are very close in terms of the field, but exactly, I was working closely with industry clinicians and the research, bringing all of them together to connect all the expertise together to be able to help the patients for a better quality of life. And we all know that by using 3D printing, we can easily convert the MRI or CT scan data into 3D printable data, and then we can actually create a customized patient-specific component. As we know, all the children, adults are all coming with a different size of body shapes. And for instance, for the craniofacial disease, you can actually take the MRI data of the patient, or for a hip implant, to create exactly the same size of the patient's body. And that helps to minimize a lot of costs for NHS, because you will minimize a lot of rejection from the patient body. And you actually, by using 3D printing and creating the customized parts for the patient, you can actually decrease the NHS costs as well as the patient discomfort. So that was my background. Yeah.
Thank you so much, Paris. And while we're still just on medical, I want to pass it back around to Beth, as you say, of this kind of similar understanding here. So, Beth, I'm really interested because during the nomination process, one of our nominators actually praised you for, I quote, a healthcare renaissance in point of care product development and manufacturing, which is a pretty decent accolade. So, working with the VHA, you really are at the forefront of the largest integrated healthcare network in the United States. Can you talk about some of the challenges in adopting 3D printing into such a huge organization like this?
Yeah, absolutely. I think it's deceptively simple when you think about 3D printing at first. And I think many of us might have started with a desktop 3D printer. You can buy it at a low price point, plug it in, plug and play. But as all the panelists have been alluding to, there is a lot of work that needs to go into it behind it. If you're not just making, a baby Yoda, right? If you're making a heart for a patient, you need to know that it's accurate, right? And that it really, all the dimensions are correct, et cetera. So there's a lot, and I'm preaching to the choir here, but there's a lot of training that goes into this. There's a lot of engineering that's required. So step one for us really is just to think about, as we do this and as we roll this out, what is the training and what is the type of staff that we need? And bringing engineers in, right next to the physicians is a really important step forward that we're able to do. Also research, and we've been talking about new materials, different types of properties. So bringing researchers, engineers, clinical staff. She wants to be on camera, Raven, and all of that together, right? It is a feat. But the amazing thing about hospitals is it's a great place to do that. And of course, our industry partners too. And so VHA is, very interested in partnering with anyone who wants to improve veterans' healthcare. So, bringing them into. So I would say that's number one. Number two is really trying to harness that distributed nature of printers. So I mentioned we have 99 hospitals that have 3D printers, and we have 6 hospitals that are really hub sites where we put a lot of that engineering and clinical know-how. But how do we share files across the sites? Again, deceptively simple when you first think about it. Just send it over. But now when it's patient information, or it's essential information, or it's information that you need to be able to trust is the right file, what is the infrastructure that's needed to digitally share these? During the pandemic, this became a big issue, and big shout out to one of my favorite women in 3D printing, Megan McCarthy, if you don't know her, from the NIH 3D Print Exchange, and Phil Cruz, who set up the NIH, who created NIH 3D Print Exchange, which is an accurate, safe, trusted source for 3D printed files or digital files. And then, I think number 3 is actually, it seems a little more pedestrian, but it's equally important. If you're going to do point of care manufacturing and you want to get the printers into the hospital, you have to have the facilities to do it. And again, plug and play seems simple at first, but when you start to think about all the different types of technologies that you want to bring in, you've got to have, you separating your powder printers from your vat photopolymerization primers. Do you have the right power pulled in? Do you have the right ventilation? If you're bringing metal in, that's a whole nother game. So, really working on that. And all of this to say, one of the things I'm really proud of from VHA is that as a government organization, we also have, kind of a side mission to share out what we learn with the general public. So we've been working on a playbook to help explain how to do this point of care manufacturing. It's kind of in its early iterations, but you'll see us hit again those three themes, training and getting the right people to the table, getting the printers in a safe environment. And then probably the most challenging but most exciting for us as an industry is building that digital infrastructure that's going to allow us to share and move files either between ourselves within our own organizations or across, the ocean, right, to my colleagues over in Europe and beyond, and making sure that that's trusted, safe, and verified.
Yeah, that sharing is so important. Thanks, Beth. And back to Parastu now, and now we still have you here. So just kind of actually a little bit on that idea of sharing and cross-industry knowledge as well, because Parastu, you have this extensive background in additive manufacturing in medical, and with lots of research focused on utilizing the design flexibility of AM to create patient-specific devices. But you're also currently working on another project exploring new industries with another Birmingham-based company. Can you share what maybe you've learned there and what kind of learning you're passing on into these new industries?
Yes, I've actually, since 2 years ago, I started working with a Birmingham company based. It's a jewelry company, and I've tried to use my AM knowledge. It was started with a knowledge transfer partnership kind of project. And we tried to transfer all the knowledge of what we've got from AM to the company to actually expanding and diversifying the business model of that company into a new sectors, because there was the company's actually main focus is on jewelry, but we were trying to use the precious metal application of the precious metal, because we all actually now talking about the new material. So I'm actually trying to now investigate the application of the precious metal for different fields, for instance, medical and then industrial. So we are working on volume production of industrial components, for instance, for glass fiber manufacturing, but they're all the same concept. We are working on a different design. And also we are actually trying to expand the new sectors in the jewelry company for medical application, because we know that the precious metals are very important for dental and medical application. By very small incorporation of the precious metal, because we know that the precious metal is very expensive, so probably it's not a good idea to print the whole things with the precious metal, but very small amount of precious metal into the main matrix of, for instance, titanium or other metal, cobalt, chromium, or copper, they might actually can make a big difference to create a new component for medical or dental application. So, and then, yeah, I'm working on it and I'm very excited because, we are trying to develop this into the company, and the company business model is entering to the new sector. So that's very challenging, but everything's going very well.
Great, thank you. And I can't believe how quickly we've managed to run through these questions today. And I think Greg will be joining again in a second to kick me off. But I just want to make sure that I ask this question to all of you. I'm really interested to get your expertise as people with all completely different experience in the additive manufacturing industry. If you can answer kind of briefly if possible, but is there a challenge or maybe an opportunity within this industry that you think we need to be really talking about more? I'll pass it to Kate first. We'll try and go in sort of the same order.
Yeah, tricky one, that tricky question. But I think really it's about trying to get the ecosystem together. people talk about the additive manufacturing ecosystem, but there are still many people working in silos. I don't think we're going to create the innovation that we need or take additive manufacturing to the levels that it could without the ecosystem working well together. So it's really about getting businesses, companies from all breadths and walks of life working together to get additive manufacturing to the level it needs to be.
Great. Alba, what about you?
I'm gonna agree with Kate. I think she's right what she says. In the medical industry, I think hospitals, manufacturers, research, we all have different focuses, and we should all come together and actually work together. I'm gonna say as well, in my field and for medical implantable devices that need to stay in patients for many years, I'm gonna say regulation, because we are asked to comply with an ISO 13485 standard, but there are not really, there is a lack of specific technical requirements that the specific 3D printed implant needs to meet. So we see that different manufacturers use different workflows and post-processes to develop the same type of implants. So let's say to develop a femur, one manufacturer uses different post-processes, other different post-processes, and that leads to different mechanical properties of the implants, and are implants that withstand high loads and so on. So I think regulation is a topic that we need to work more on and come up with standards for the industry. We all use the same processes, post-processing, and so on. In our case, we have spent a lot of time and resources making sure that the 3D printing of our metallic implants have the appropriate microstructure to meet mechanical functions of the body, so on, so on. So I would like to see a standard that says what everybody should do to develop specific devices.
I'm sure there'd be a lot of people in the industry agreeing with that as well. Jessica, what about you?
Yeah, in the space of resin additive manufacturing, I think the biggest thing is trying to find applications where 3D printing can be used for manufacturing. And there's two big things that go into that I think need some attention. One is cost competition with injection molding. Injection molding obviously can be very cheap, but additive does have a lot of values. Specifically, of course, just-in-time manufacturing, freedom of design, which can lead to lightweighting or improved performance. And so I think finding applications where the value propositions of 3D printing fit is one of the challenges that we have right now. The second one is education of the engineers that design parts. Again, I'll hold up my midsole because I have it available. You need to have engineers that are thinking about different ways of manufacturing, whether it's for a midsole, a medical device, dental applications, industrial parts. If additive isn't in their toolbook of design tools, then it's just going to get, the opportunities are going to get missed. So I think education, starting all the way from the high school level, I mentioned my mom, but obviously through college, graduate school, and also just industrially, everyone needs to be aware that additive manufacturing can be a viable technology.
Great. Beth, how about you?
I'm going to go with, I love this ecosystem call that, that Kate started for us here, and then we've all kind of been amplifying. I think we have to do that. We have to bring together all the stakeholders, again, industry, end users, and then again, putting on my government, being part of the VHA and really seeing what big government can do. I say bring government to the table too. And that's going to help with the regulatory stories, et cetera. I think that all of our respective regulatory partners, here in the U.S., the Food and Drug Administration, have been really amazing in this field in trying to think proactively with us and continue to talk about it. And I think we just keep that conversation going. And I think, this field being new, we have an opportunity to do it right. And break down those silos and break down those barriers and understand that together we will go further. So I'm going to just amplify on that and say, let's do it.
Great. And finally, Paristu, what about you?
comment on this is a combination of Kate and Alba and Laura in terms of the medical application, as well as I'm 100% agree with Jessica as well. But I think ecosystem is one thing, and the other things are always things that there are lots of funded research are happening regarding for instance, the novel technology of 3D printing for medical application. But unfortunately, I think these researchers is going to be left somewhere, which I think we need to have a kind of extra funding to follow the regulation to get to the clinical trials, because there are lots of, for instance, research happening by a researcher. But at some point, for instance, after 3 years of funding, it's going to be left, and then the next project, according to the written proposal, is going to be started. But I think it has to be followed kind of funded project to check all the kind of tick the boxes, what is required for that medical or for that research to be done to get to the clinic. This is I think I see the lack of these kind of things as well. So because it's a novel technology and it's very it's in contact with the human bodies, the toxicity, everything is have a kind of a direct impact on the human's life. So I think we need to actually work harder, because it's valuable that we got a lot of funding and the research is going on for 3-4 years, but I want them to have a kind of conclusion, like final decision, what happened for that research, what types of product can come out of the project, in terms of the looking from the commercial point of view.
Yeah, lots of stuff to consider there. Thank you so much. I could really just speak to you all for another hour, but I know we've already gone over time. So that really just leaves me to say now the vote is now open for the TCT Women in 3D Printing Innovator Award. So please head over to tctawards.com where you can vote for this year's winner. And then you can also join us as well when we announce the winner at the TCT Awards ceremony on the 7th of June in Birmingham, UK. So it'd be great to see you all there. So once again, thank you so much for each of our finalists for joining us today. I know we've got some different time zones to contend with, some very early starts for some people, so it's very much appreciated. And congratulations again, all very, very well-deserved finalists this year. Thanks so much.
Thank you very much, Laura.